Good day, class! Last time I told you to have an advanced study about our next topic, the laminar flow. So today, we will have a graded recitation. First, how can you describe a laminar flow? Yes, Miss Aberisto? Do you want to answer?
In laminar flow, the fluid particles move in orderly manner, with each layer sliding past the adjacent layers. The velocity of the fluid is highest at the center of the flow and gradually decreases towards the edge. So this results in well-defined flow patterns and streamlines. The behavior of laminar flow can be described by the Navier-Stokes equations, which are mechanical equations that govern fluid dynamic. These equations take into account factors such as fluid viscosity, pressure, and velocity to predict the flow behavior.
That's right. In laminar flow, the fluid particles move along in well-defined paths or streamline. Next is the nature of laminar flow. Ms. Rayos, what is the nature of laminar flow?
Fluid layers slide in parallel with no eddies, swirl, or current normal to the flow. This type of flow is also referred to as streamline flow because it is characterized by non-crossing streamline. That means every fluid particle follows the same trajectory of its preceding particle.
That's correct. Thank you, Ms. Rayos. Let's proceed to the characteristics of laminar flow. Who wants to answer? Yes, Ms. Cabase. Yes po, ma'am. Here are the characteristics based from my research po. Number 1, laminar flow is characterized by regular and predictable behavior due to its smooth and orderly movement. This predictable behavior is a result of several factors including the low velocity and viscosity of the fluid, the well-defined boundaries of the flow, and the absence of turbulence. Number 2, viscous force plays a crucial role in laminar flow. It is responsible for the resistance to the movement of fluid particles and contributes to the smooth and orderly nature of laminar flow. Number 3, shear stress is a concept in fluid dynamics that describes the force per unit area acting parallel to the surface of the fluid when there is a velocity gradient or a difference in velocity between adjacent fluid layers. It is given by Newton's law of viscosity, which states that the shear stress is directly proportional to the rate of velocity change or velocity gradient and the dynamic viscosity of the fluid. Number 4. In laminar flow, the velocity distribution is often observed in the parabolic in nature. This means that the velocity of the fluid varies along a cross-section of the flow domain in a parabolic shape. The parabolic velocity distribution arises due to the influence of viscous forces and the no-slip conditions at the walls of the conduit through which the fluid is flowing. The parabolic velocity distribution is a characteristic feature of laminar flow in confined geometries such as pipes or channels, where the flow is well contained within the specific boundaries. It is a result of balance between the pressure gradient and the viscous forces acting on the fluid particles. Number 5. Loss of head, also known as the head loss or pressure loss, refers to the decrease in fluid pressure or energy as it flows through a pipe, channel, or any other conduit. In laminar flow, the loss of head is directly proportional to the velocity of flow, according to Darcy-Weisbach equation, which is commonly used to calculate head loss in fluid flow. The head loss due to friction is proportional to the square of velocity of flow. This means that as the velocity of flow increases, the head loss due to friction also increases. Number 6. Laminar flow can occur in both steady and unsteady conditions, depending on whether the flow parameters remain constant or change with time. Steady laminar flow. In steady laminar flow, the flow parameters such as velocity, pressure, and cross-sectional area remain constant over time. The fluid particles move in a well-defined and consistent manner, maintaining the same velocity profile and pattern throughout the flow domain. The streamlines remain fixed and do not change their shape or position. In unsteady laminar flow, the parameters change with time. This can occur due to variations in flow rate, pressure, or other external factors influencing the flow. The fluid particles do not follow a consistent pattern and the streamlines can change their shape, position, or direction. That's correct. Thank you, Ms. Cabase. And the last is the practical example of laminar flow. Mr. Arnel, you want to say something?
There are 5 examples of practical in laminar flow. So first, certainly, the flow of blood through veins is an essential part of the circulatory system which is responsible for delivering oxygen and nutrients to cells and removing waste product from the body. The second one is the flow of liquid through porous media refers to the movement of a liquid substance through a material or medium that has interconnected spaces or voids known as pores. Porous media can include materials such as soil, sand, rocks, or even man-made materials like filters or membranes. And the third, the rise of sap interest refers to the upward movement of sap, which is a watery fluid containing water, nutrients, sugar, hormones, and other substances within the vascular system of plants. This process is also known as sap ascent or sap flow. The rise of sap interest occurs primarily due to a combination of several physical processes. Root pressure. Root active absorb water from the soil through osmosis, creating a higher pressure in the roots compared to the stem. This root pressure can push water upward in the xylem vessels, particularly in certain conditions like when the soil is well hydrated or during periods of high transpiration demand. Capillary action. Capillary action is also known as capillarity. Is the phenomenon by which liquid can rise against gravity in narrow spaces such as the tiny tubes within the xylem vessels. Transpiration. Transpiration is the process by which water vapor escape from the leaves through tiny openings called stomata. As water is lost through transpiration, it creates a negative pressure or tension in the xylem vessels. In the number 4, the flow of oil in a lubrication mechanism refers to the movement of oil within a system or machine to provide lubrication and reduce friction between moving parts. Lubrication is essential in the machinery to prevent wear, heat buildup, and damage caused by metal-to-metal contact. In a lubrication mechanism, oil is used as lubricant to form a thin film or layer between the moving surfaces. This oil film reduces friction and allows the part to slide or rotate smoothly against each other. It also helps to dissipate heat generated during operation and act as a protective barrier and against contaminants and corrosion. And the last, number 5, the flow of fluid in a capillary tube refers to the movement of a liquid or gas through a narrow tube or capillary with a small internal diameter. Capillary tubes are characterized by their small size and high surface to volume ratio, which can significantly influence the behavior of fluid flow. The flow of fluid in a capillary tube is governed by several factors, including the properties of the fluid, the dimension of the capillary in the forces acting on the system. Key factors that influence the flow include surface, tension, viscosity, pressure, differentials, and the geometry of the capillary.
That's right. Thank you, Mr. Arnel. That ends our topic for today. Goodbye, class.
Goodbye, ma'am.
Bye,